Our next random sampling method is called stratified sampling. Stratified sampling. We use this sampling method when there is a particular characteristic in a population that we really need to capture. Okay? When we want to really be sure we capture a characteristic in a population. I should say from a population. Okay. Okay. So what does that mean in practice? What we do for stratified sampling is we divide the population to what are called strata. They're just groups, but they're groups that have the different properties of the characteristic we want to capture. Okay? Divide the population into different groups called strata. Okay, that strata word, that's where we get stratified sampling. We're dividing the population into different groups called strata. Then we sample each group proportionately to how large that group is. So sample each strata in proportion to the size of it. In proportion to the size of the strata. Okay. If you haven't heard this word strata before, where I most associate it is in geology. Sometimes you see rocks with like different layers, and sometimes those layers are thin and sometimes they're thick. Those are called strata in geology. Those are different strata. We're doing kind of the same thing here. We're looking at the population, and it's represented by a characteristic, but that characteristic could have a different property. So, you know, maybe there's one group. That's not what I want. One group, and it's, you know, this big relative to the population. And the next group isn't quite as big. Maybe it's like this. And then we maybe have a really tiny group. And then maybe a great big group. Okay? And we want to make sure that in our sample it has all these characteristics accurately represented. Okay? So imagine this is kind of like a cake, and we're taking a slice of it. If we take a slice out of this cake, okay, this is our slice. Okay? Then this slice will have this section in blue, the blue section, just as big as in the population. This section, just as big as in the population. This little section here is just as big in the sample relative to the population. It's just as small in that sample, right? So it's easiest to think about it in percents. If, say, this blue section is 25% of the population, then when we sample it, we want it to be 25% of the sample. If the red section here is 10% of the population, when we sample it, we want it to be 10% of the sample. If the green section is 2% of the population, then when we sample it, we want it to make up 2% of the sample. And so we are preserving that characteristic that's in the population for the sample. Now, random sampling generally should preserve that, but sometimes we want to be extra sure that a characteristic is preserved. Random sampling, there can be some variation. Sometimes some characteristics aren't preserved as well as we would like. And sometimes we want to be extra sure that a characteristic, an important characteristic, one characteristic that we know is important, is accurately reflected in the sample. Okay? So that's essentially how we do it. We identify the different strata, we identify how big it is in the population, and then we randomly sample from each strata so that it stays proportionate to how big it is in the population. Okay? So let's take a look at an example here. So hopefully you can read that. I know the text is a little small, but we have 3 students here, or 3 groups of students. We have grade A students, we have grade B students, and we have grade C or lower students, okay, in this class. Now, we want to sample 6 students, but we're going to do this using stratified sampling so that the size of each group remains proportionate in the sample, okay? So to do that, we need to know the proportionate size of each of our strata here, okay? So for this first group, okay, there are 10 individuals total in this group. And we know, you could count real quick, there are 30 in the population total. There are 30 students in this class. Okay, so this group makes up 10 out of the 30 students. Okay, which means it's 1/3 of the size of the group. So since this, if we reduce, that's 1/3. Okay, or 0.3333. Actually, let me write that in the next line. Okay, if we throw that in the calculator, we'll get a bunch of 3's, or 33.33%. Okay, however you want to display it, it's all different ways to express the same idea. Since this group makes up 1/3 of the population, or 33.33% of the population, and when we sample it, we want 1/3 of the students in our sample to come from this group. Okay, so we will randomly sample that group so that 1/3 come from it. Okay, what about this group here? Okay, in this case, there are 15 students in the group. So that means 15 out of the 30 students come from this second group, the grade B students. That's 1/2 if you reduce that. 0.5 is a decimal. If you take 1 divided by 2, you'll get 0.5. Or if you convert it to a percent, that's 50%. To convert to a percent, just take your decimal and move it 2 places right. Okay, that's a percent. Okay, which means we want half the students in our sample to come from this group. Okay, and one more. We have the grade C or lower students. There's 5 students in this group. 5 of the students out of the 30 total come from this group. Okay, if we reduce that fraction, that's 1/6. If you throw that in a calculator, this one I do not have memorized, so we could throw this into a calculator to see what the decimal representation is. 0.1666667. It actually goes 6's forever, but it rounded it off. So we just need a few 6's there. 0.16667, okay, or 16.667%. So we want 1/6 of the students in our sample to be in this grade C or lower group. Okay, so now that we know the fraction or proportion or percent of students that we want in each group or from each group, let's figure out what that means in terms of the actual number of students we're sampling. Okay. So for this first group, we want 1/3 of our students to come from this group. Now remember, we want our sample size to be 6. We're sampling 6 students total. So how many total students are we going to sample from this group or this strata? So to find that out, all we do is we take our fraction here, or you could take the decimal form, whichever one, and we're going to multiply it by the total. Okay? So I'm just going to take 1/3, and I'm going to multiply it by our total 6. Okay, so if I take that 1/3 and multiply it by 6, I get 2. You could probably have done that without the calculator, but it's there if you need it. 2. So 2 of our students will come from this group. Okay, 2 of the students that we sample will come from this group. We want to do the same thing here. We want half our students to come from this group. So 1/2 times the total students we want to sample is 6. So that is 3. And again, you could throw that into your calculator. And there are different ways you could do this, right? Any of these numbers is equivalent. The only one you don't want to use when doing the math is percent. Whenever we're doing math, we need to convert percent to decimal form. So don't use the percent. But if you take any one of these and multiply it by 6, you get the same thing. So why don't I use the unsimplified version this time, 15 out of 30. Okay, so if I use 15 out of 30 times 6, I get 3. That's the same as 1/2 times 6 because it means the same thing. It's 3, or 0.5 times 6. Okay, all different ways to write the same idea. Okay, we get 3 in each case. So that means 3 of our students comes from that group of grade B students, that strata. So when we do our random sampling, we need to choose 3 students from that group. Okay, one more. How many students come from this strata? Okay, we take our fraction, and again, any one of these would work, just don't use the percent. Okay, in math, whenever we have percents, we need to first convert it back to decimal form, convert it to something else to use it when we're actually doing math with it. Okay, so I'm going to use 1/6. I like the fractions. 1/6. I'm going to multiply that by 6. You can see pretty quickly that's going to just be 1. You can use your calculator if you want to, but 1/6 times 6 is 1. So 1 student will come, in our sample, will come from this group. Okay? Okay, that's the hard part done. Now all we need to do is sample which students are actually going to be in our sample. Okay? So let's do this first group first. We want 2 students out of one of these 10. Okay? So I'm going to use my sample function, and I want one of those 10 students. So the first student was number 1, the last student was number 10, and I have calculated that I need 2 students from that group. Okay? So I'm going to randomly choose 2 of those students, and using the computer, we've randomly chosen student 2 and student 3. Okay? So looking at this group, student 2 and student 3, that's Cheng and Hong. So they're going to be our first students in our sample. There we go. Okay, and they're my grade A students. So I know that my grade A students are represented in my sample because I've chosen Cheng and Hong, and so 1/3 of the students in my sample will be grade A students, just like 1/3 of the students in my population are grade A students. Okay? Grade B students. In this case, I also have my students numbered. They're numbered from 1 to 15. Okay? And I want to choose 3 of them. So let's use our calculator. For this second group, my students are numbered from 1 to 15, and I want to choose 3 of them. So I'm going to use the sample function, and the computer is going to randomly select 3 of my students. And the computer picks student 15, student 9, and student 2. So if we go back, we have student 15, Wei, student 9, Cuison, and student 2, Bayani. Okay? And so now I have the students in this strata represented in my sample. Half of the students in my sample are grade B students, just like a half of the students in my population are grade B students. Okay? One more strata to go. I need to do my grade C or lower students. Okay? So for this, I just want to choose one student, okay? And my students are numbered from 1 to 5. I only have 5 students. So I use my sample function once again. And I'm only choosing one student from this group. Evaluate, and I chose student 4. Okay? Student 4 in this group is Raoul. And so that's the last student. I now have 6 students chosen, and I've chosen them in such a way that grade A students, grade B students, and grade C students are represented in my sample exactly how they are in the population.